Hello learners. Today I will teach you how you can calculate association, or how we can find it out association between two variables with the help of chi-square test. So for that, first of all, we have to formulate a null hypothesis. So let's take an example of one null hypothesis, that there is no significant association between knowledge regarding cancer with selected demographic variable such as sex, education level, history of cancer, etc. So with chi-square test, we can find it out association between two variables. So first of all, let's find it out the association between knowledge score with age. So for that, first of all, we have to learn the formula to check the chi-square. So the formula is x square. So this indicate chi-square equal to summation of observed value minus expected value whole square divided by expected value. So O4 stands for observed value, E stands for expected value. So first of all, you have to make a contingency table or chi-square table of your data. So this is one of my chi-square table of one research study. So where I have placed a number of or the age categories in the x-axis and the knowledge score in the y-axis. So these are the frequencies, and these frequencies are called observed frequency. So first of all, we'll write the observed frequencies one by one. So 0 1 means this one observed frequency, the first observed frequency, that is 5. This is the second observed frequency, this is the third observed frequency. Means when we have collected the data, we have seen this frequency in these categories of age which have poor knowledge, moderate knowledge, and good knowledge. So these are our observed category. Now as you can see, the chi-square formula is observed value minus expected value. Means observed value we already have, now we need a expected value. So to calculate that, we have a formula of calculating expected value is raw total into column total divided by grand total. So means from this contingency table or from this chi-square table, we have to calculate the raw total and the column total. So these are our row. We have 3 rows, right? 1 2 3 3 rows of this age categories. So first of all, you have to calculate the expected value, we need raw total and column total. So suppose we have 3 row, so just add this value of this rows. So suppose 5 2 3, so total is 10, then 3 2 10, total 15, 2 2 1 5. So these are the total of our values which is in this different rows. Then next we have to calculate the total of the values which is present in columns. So you can see for the first column, this is the total value, for the second column this is the total value, and for the third column this is the total value. Then if you calculate vertically and horizontally, you will get 30. Because why? Because 30 is our sample size, and these 30 samples scattered in the different categories based on their score and based on their age category. So these are our frequency. What frequency these are? These are our observed frequency that we have observed when we have collected the data, and these are the total of our observed frequency. Calculate expected frequency for each of the observed frequency. As we have total 9 observed frequencies, so we have to calculate expected frequency for each of the observed frequency. So first our observed frequency is 5. So for these 5 we have to calculate the expected frequency to calculate chi-square, because for chi-square we need the expected value. Observed value we already have. Now what we have to calculate? We have to calculate the expected value, and the formula is raw total into column total divided by grand total. So we have the raw totals, these are the raw totals, these are the column totals. Now we are ready to calculate the expected value for all these observed frequencies. So now let's calculate the expected values. So first one, so this first value, right? So for observed frequency 1, that is 5, expected frequency will be, or expected value will be, we will place this formula, raw total column total divided by grand total. So raw total means, see, we are calculating expected frequency for this value, right? The value number 1, observe value number 1. So for this, the raw total is how much? Because this value fall in this row, right? And the total of this row is 10. So we are placing 10 because it is written here raw total, right? So 10 into column total. So this particular value fall in this column. So what is the total of this column? That is 10. So we will write 10 divided by what is written, grand total. So we see what is our grand total. Our grand total is 30. So we will write 30. So if we calculate this, then we will get 3.3. So again, we have to calculate expected frequency for observed frequency number 2. This is observed frequency is what? Observed frequency 2 is 2, right? So again we will calculate same way, and with the result we got 2. Then again we have to calculate expected frequency for observed frequency 3. So observed frequency 3 is 3, right? So we have to calculate the expected frequency with the help of this formula. Then we have to calculate expected frequency for observed frequency 4. So see in this table, what is the observed frequency for 1, 1, 2, 3, 4. This is the fourth number value, right? So for this fourth number value, we will calculate the expected value. So formula will apply raw total, column total, isn't it, and grand total. So raw total is what? So we are talking about this value, right? So this value fall in this row. What is the total of this row? It is 15. So we have written the 15. Then we have to write column total. So this particular value, we are talking about this particular value number 4. So this fall in this column. So what is the total of this column? 10 divided by grand total 35. So this is how you have to calculate expected frequency for all the 9 observed frequency. We have 9 observed frequency, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have listed out, right? So for all the observed frequency, we have to calculate the expected frequency. Now we have the expected frequency. So now we can calculate our chi-square, because chi-square formula is observed frequency minus expected frequency. So we have all the expected frequency and observed frequency. Now we are ready to calculate the chi-square. Okay, so first of all, we have to calculate chi-square for each frequency. So each frequency means, you see, this 9 frequency, right? So we have to calculate the chi-square for each of the frequency or each of the number. For we have to calculate chi-square for number 1 observed value, for number 2 observed value, for 3, for 5, 6, 7, 8. So we have to calculate total 9 chi-square. We have to calculate total 9 chi-square values. So suppose this is for the observed value 1. So observed value is what? You can see here. Observed value 1 is 5, right? So for 5 we will calculate the chi-square, first chi-square. So formula of calculating the chi-square for each frequency is observed value minus expected value divided by expected value. So 5 is our observed value, first observed value. So let's take this. So 5 is our first observed value, isn't it? So we have wrote here 5 minus expected value. First expected value is how much? So you can see the first expected value is 0.3. So we have written 0.3. Then divided by expected value, divided by expected value. So we have written expected value and we got this result, right? So same way you have to do it for the another expected value. So the second expected value, observed value is 2, and the expected value of this observed value is also 2. Then we have to calculate the chi-square for this second observed value. So let's see. So chi-square of second observed value. We have written second, right? This means we are calculating chi-square for second number observed value. So here you can write 2 minus 2 divided by 2. Why 2? Because in this case observed value is also 2 and calculate value is also 2. That's why 2 minus 2 divided by means whole square divided by 2. So it will be 0, isn't it? So this is how we have to calculate total 9 chi-square value, because we have total 9 frequency, isn't it? So we have our total chi-square 9 chi-square value, and from here we will calculate the chi-square for whole sample. So this is the formula of calculating the chi-square for whole sample. So in this example, we took the sample size 30. Means in my study, it was a pilot study, so it was sample size was 30, and I am calculating the chi-square for this 30 samples. So now first of all, we have calculate the chi-square for individual frequencies. Means for each frequencies we have calculate the chi-square. As we have 9, so we have calculated 9. From this we will calculate the chi-square for whole of the sample. So the formula is chi-square, this df means degree of freedom, equal to summation of observed value minus expected value whole square divided by e. So we have already calculated observed value minus expected value for all the frequencies, right? So now we will just add those. So we will just add those values that we have already calculated. So summation of x1 chi-square value for first observed value, chi-square value for second observed value, chi-square for third number observed value, fourth number observed value, 5 number, and 9. So we have already placed the values, and then we got this total, that is 5.95, and this value is called calculated chi-square value. Why it is calculated? Because we have calculated it, right? So that's why it's called calculated chi-square value, which is 5.95. Now it's the time for interpretations, because we have already calculated the chi-square. Now we have to interpret the result. So for interpretation we can do in 2 ways. So first one, if your calculated value, if it is greater than tabulated value, then we will reject the null hypothesis. If calculated value is less than tabulated value, then we will accept the null hypothesis. The null hypothesis means the hypothesis that we have already formulated. So you can see this is our null hypothesis. What we have written here, that there is no significant association. We have considered that there is no significant association between S with the knowledge score. So this is our null hypothesis. So if what is written in the interpretation section, then it is written, if the calculated value we got after calculating it, that chi-square value, if it is bigger or if it is greater than the tabulated chi-square value, we will reject this null hypothesis. Means we will reject that there is no significant association. That means there is a significant association between S with the knowledge score. So for that you need to calculate one more thing, that is degree of freedom. So degree of freedom is what? That is row minus 1, column minus 1. So row means I am talking about our chi-square table. See how many row is there in our chi-square table? We have 3 row, 1 2 3. So we will write 3 minus 1, 3 minus 1, then into column minus 1. So how many column we have? 1 2 3, that is 3 minus 1. So what is the degree of freedom? Degree of freedom is 4. And level of significance that we are considering, it is 0.05, because we have already written it, right? We have already written it in our hypothesis that sorry, I forgot, etc. at 0.05 level of significance. Level of significance. So now we have calculated value, we have degree of freedom, and we have level of significance, right? So let's write it. Our calculated value is calculated value is how much? We got the calculated value is 5.95. 5.95. Then degree of freedom is 4 and level of significance 0.05. Now we have to see for tabulated value. See for tabulated, because why we need tabulated value? Because we are going to compare our calculated value with the tabulated value, right? So we have to find it out what is the tabulated value, and for that, so this is our chi-square table that you will get in Google, and also you'll get in your research book. So we have already calculated degree of freedom is 4 and level of significance is 0.05. so now, and we have our calculated data. So we will see what is the tabulated value in this chi-square table. So our degree of freedom is 4 and we will observe the value at 0.05. So you can see what is the tabulated value. Tabulated value is 9.48. So this is the 0.05 level of significance column, and our degree of freedom is how much we got by calculating it. We got 4. So you have to see here. So this is 4, right? So you just go in this direction, and then under 0.05 you have to observe your tabulated data. So the data, it is 9.48. So here I have already written that is 9448. Now we have already, so now we will do the interpretation. So I have already written, so this is our calculated data. So calculated value, see, this is our calculated value, isn't it? We got this by calculating chi-square, and this is our tabulated value that we got by from the chi-square table. So it is written here in interpretation section that if you find your calculated data or calculated chi-square value is less than the tabulated chi-square value, as our calculated chi-square value is less than tabulated chi-square value, that means we have to accept the null hypothesis. So we have to accept the null hypothesis means what? That means we have to accept that there is no relation, there is no significant association between age with knowledge score. As we have observed this, because this frequency table is for age, right? So that's why we can interpret like this, that there is, as this our interpretation is explaining us, or interpretation is indicating us to accept the null hypothesis, because our calculated value is, it is lesser or it is smaller than the tabulated value. Yes, so we have to accept the null hypothesis. So we have to accept the null hypothesis means we have to accept that there is no significant relationship between age with knowledge score. So this is how you can see the association between educational level with knowledge score, and you can see the association between history of cancer. So here you have to write the history of cancer, yes, no, and here you have to write the knowledge score, poor, moderate, good, and then you have to compare it with the help of chi-square test.